is asking us to what? Check the given force is a conservative or not. So what is the best method? I'll choose the path. Path ABC, I'll find out the work. Path AC, I'll find out the work. Path ADC, I'll find out the work. If work done is in different path, work done is same, then what you can say, it's a conservative. If the work done is different in different path, it's a non-conservative. All of you got the method? Different. So I'll directly proceed with the problem. Work done along the path ABC. For work done along path ABC, what you should do? Work done along AB plus BC. No, I'll start first with work done along the path AB. What is the force? F bar dot dx I cap. What should be the limit? 0, 1. This is very important. So you do come across frequently numericals of this kind. I dot j will cancel out, so we'll end up with 2 xy dx 0 to comma. What to do with y? What has initially or started from here, no? A to B. So what is the value of y? Y should be 1 or y should be 0, no? So in the limit, it will be 0 to, I'll write one more step, no? It'll be easy for you. What is the value of y? You should write 0, no? So therefore, the next step, what you get? Work done. So this will end up with 0. Now, why that? What do that arrow indicates? Because you should substitute the value of y. That's why it has become 0 here. Just I'm helping you with this. Some voice is crackling up. Can you hear me now clearly?
Yes, sir.
Work done along the path BC. Just it's a procedure, nothing to do. There's no concept, just mathematical procedure it is. Just you have to follow. Now, when you're moving from B to C, what should be the limit for y? 0, 1. So I'll start like this. F bar dot dy j cap. So directly I'll write it. So this should be, okay, 2xy I cap plus y square j cap. So this should be y square dy 0 to 1. So this will be 1 by 3 after integrating. What is value of x? Actually, the value of x is how much will be there, but j dot I will become 0. No, I didn't bother to substitute anything. So let's do one thing. What is the work done? By the force along the path ABC. So shall I add up? WAB plus WBC. So this should be 0 plus 1 by 3. So 1 by 3 joule. So we can't pick up this option. This is ruled out. And let's go for other path. Other path is AC, I'll take it. Work done along ADC, we'll check it. So first along the path AD, then DC. Shall I at a time integrate total? So instead of breaking up into the parts, I'll go for direct. This will be. So what should be the limit? 0, 0 to 1, 1. So this will be F bar dot dr bar. Can we directly integrate here? Can we do directly like this? Or we should do individually only? I think both are same, no? both are same. So I'll take the next step. So this will be 2x y I cap. Now 0, 0, 1, 1. We know what is the path. So this will be, let me write 2xy dx y square dy. No, okay. How you are going to substitute? So where you are initially, you are at 0, 0, no? You are at 0, 0 and you are moving 0, 1, then 1, 1. I think I'll show the diagram. Try to see that one. First, what happened? You are at A. Try to see all of you. So first you'll move from A to D, no? So what if the limit 0, 1 will come? So what is at D also, what is the value of x? X will be 0 only. Then you are moving from D to C. D to C, what happened? The value of x will change. So first you are moving along y-axis, no? Able to make it, first you are integrating along y-axis, then along x-axis here, not along first x-axis, then y-axis. Because the path is ADC. So here the big trouble will come. The students will try to put here y0 something. You have to be alert. First you should integrate along y-axis, then along axis. I'll rearrange this bracket. First the limit. So it should be 0, 0. Okay, fine. So now first the limit should be like this. 0, 1. Y squared. There is no x, though, no to problem. Integrating now where you are available, you are. So what should be the limit for
So voice is
x 0 to 1? What you should write in place of y?
Can't hear you properly.
Can you hear me now?
No, sir.
No, sir, breaking, sir.
Still breaking. Every day I think there's a second day, no? Never happened. Can you hear me? No, clearly?
yes, sir.
Yes, sir.
Okay. No, all of you looking at the, I just, because I had to show the diagram also, A, D, comma, C, all that one. With this one. So first, what should be the, after integrating, what is value of y? Shall I write y here, red color arrow? Shall I write 0 or 1? It should be 1, not 0. If it were x anywhere here, I would have wrote 0, that one. Since there is no x for y squared dy, no? So we'll end up like that. So work done along the path ADC. Y cube by 3. So this will be 1 by 3 plus, no, this should be 2 into, I'll substitute value of y as 1. The green color also I'm giving so that it will help you. And then integral of x dx, what you get? X square by 2. One step will write it, no problem. See this, so this will be 1 by 3 plus 2, the bracket. One problem, if you understand, I think you can manage. Nothing big is there. Only one problem you have to understand. X cube by 2, so this will be 1 by 2 only. Check now how much work done by the path ADC. This will be 4 by 3 joule, no?
Yes, sir.
So what was the question given? 14 by 5. So it is 4 by 3 it is in fact. So look at the work done by the force along ABC and along ADC. So I'll bring it here. Along ABC 1 by 3 joule. Along ADC it is 4 by 3 joule. So according to the definition of conservative force, work done is independent of path. But here what happened? The work done by the force depends on path. So can you say force conservative or non-conservative? It's a non-conservative. So therefore, F is a getting the method. So how to justify a force conservative, non-conservative? There's a like this. Like this, you should integrate along a path. You have to pick up a path. You have to choose a path. Okay, let's come for one more option is there. No work done by the force is 8 by 5 joule when particle moves along the path ABC. So work is non-conservative nature and work done along the path AC is 1 joule. He has given one path. Work done along the path AC. What is AC? 0, like a 0, 0 to 1, 1. How to calculate work done along the path AC? Let's come back to this one. So work done along the path AC will calculate. So this should be the what is the path? 0, 0, 1, 1 F bar dot dr bar. So strictly they are given a path for us. So what is that path? Is it a, shall I say I'm moving along one straight line? This is again very important for you. I'll draw the respective diagram. You can see 0. There's a point C. This is A, no? And there's a path. One comma 1, 0, 0. This is a path. So shall I say this path is a straight line? Let's say it is a straight line. Fine. So now what we should do in that specific path is telling. So let me write here 2xyi cap dot dy j cap 0, 0, 1, 1. So this will become integral of 2xy dx y square dy 0, 0, 1, 1. What we should do here is telling path. No, there is something you mentioned path here. So for this path, any equation can you write for this path? For path AC, any equation? Y equal to x. Why y equal to x? Because the equation of straight line, no, it makes angle 45 degree. Y equal to mx plus c. Slope is 45 degrees. So m is equal to 1. So therefore, for path, what is the equation? Y equal to x. So where all y is there, I can replace x. So this is that y, no? Now what happened? Here I replace that with x. Now I think now I can integrate. So work done along the path AC will be 0, 2 x square dx. Is asking work done along that path only. So therefore, using that, what happened? You should replace that y here. So this will become 2x cubed by 3 so this will become 2 by 3 plus 1 by 3. 1 joule Okay, got the answer. So sometimes when they mention path, no, you have to be very careful.
Sir, we can take 2xy plus like y square as xy square, no sir. D of xy.
That you can, but it's telling along that path, no?
Yes sir, along the path d of xy square 0 to 0 comma 1 to 1. We'll get sir 1 job.
Yeah, okay, fine. Yeah, same thing. Okay, this was the answer, no? It's telling like this. Huh? Only option C is what we can pick up here. So definitely you see work done is independent, is different in different path. So what is the basic conclusion? I think somewhere here, this I'll bring it. I'll firmly conclude that not equal to, so therefore F is a non-conservative force. If the force is work